In this video, we're going to talk about standard error and the confidence interval. If you haven't done so already, please press pause and read the standard error brief. So far this time, we have been talking about observations, distributions of observations, and we've noted that, for example, 95% of all observations fall within plus or minus 2 standard deviations. 99.8% of the observations fall between plus or minus 3 standard deviations, and 68% fall within plus or minus 1. And we've been talking about, now this is a example of a population of observations. Whenever we do a study, we estimate the standard deviation of this population by taking a sample. And so we could take a sample of 5 people, we could take a sample of 50 people. The more people we include in our sample, the better our estimate of the standard deviation is going to be. But it won't get bigger or smaller. The formula doesn't, it's just an average. And you can have a lot of numbers going into the average or small. That number won't affect the size of the standard deviation. Now, when we talk about standard error, we're talking about something completely different. It has nothing to do with observations. It does not inform you on the variability of this distribution. It is a theoretical distribution that you cannot even calculate directly. It's based on this idea that if you did this study an infinite number of times, then the variability of the samples that you would take are described by the standard error. The standard error is basically the standard deviation of this theoretical distribution of means. And you get the mean of that infinite distribution is in fact the true mean. We never know the truth. It's just not possible to figure it out. We're just going to do a sample and we're going to get an answer. And maybe we replicate the study once or twice, or somebody else replicates our study, and they give us an idea. But when we talk about a sample distribution of means, we're not saying that if you have 3 groups and you get 3 means, that this is your sampling distribution. Not at all. Each of those 3 groups has its own sampling distribution of means. And if you did the study an infinite number of times, those means would always differ, and you would have, if your sample size was 50, you'd have a narrower distribution because you'd be closer to the mean. The more you sample, the closer to the truth you come. If you only had 5, you wouldn't be as close each time. Your values would be scattered around here a lot more. And if you have a whole lot of people, then they're scattered more, but they're kind of tend to be more balanced around this central mean. Whereas in the standard error, it's just wider the fewer subjects you do. Now, one interesting thing about the central limit theorem, it says that sufficiently large samples produce normal distributions. Now, normal distribution is a particular statistical distribution that it's a theoretical distribution. It doesn't exist in the real world. We talk about our observation sometimes being approximately normally distributed, but they're not actually normally distributed. In this theoretical sample of means, you do get a normal distribution, and that's basically a bell-shaped curve. It's not skewed, and it has height that's not too flat, platykurtic, and it's not too high, leptokurtic. It's just right, mesokurtic. And this applies to any distribution. So here we have a skewed distribution. The observations are really skewed. But if you did an infinite number of samples that were sufficiently large, it would need to be about 300 in a case that has this much skew, 300 observations per sample, you would get a perfectly normal distribution. And it would be the same shape as if you had an underlying symmetric distribution. So the standard error is this distribution of means. Now, one thing that we use the standard error for is confidence interval. Now, standard deviations we're using to kind of get an idea of the variability of the underlying data. We use it in computing effect size. How are the differences between two means clinically relevant? Again, the confidence interval doesn't do that, or the standard error is not used for that. It doesn't tell you about effect size. It doesn't tell you anything about clinical relevance. What it does is it tells you how accurate are you in estimating the true mean. Now, in this particular theoretical case, we have a distribution of observations. It looks like that. It's not very many observations in each sample. We have 20 samples. And for each of those samples, we've done this study basically 20 times, and each time we've calculated a confidence interval. Notice that the confidence intervals are not the same each time. Each time we get a different standard error, and we get a different standard deviation as well, but we get a different standard error, and it gives us, when we multiply that standard error by 2 and add it to the sample mean, we get a range that goes uh, different places. Sometimes um, it'll be a big interval and sometimes it'll be a small, but 95% of the time that interval is going to overlap the true mean. This black line in the middle is the true mean, and we can see that practically all the time the confidence intervals overlap this mean. 1 out of 20 times, 5%, it's not going to overlap the truth. And so the idea is that we have this confidence that our sample is going to give us a reasonable estimate of the truth. Now, it's important to point out that we don't say that the truth falls between the upper and lower confidence interval 95% of the time. We say that the confidence interval overlaps the truth 95% of the time. It's kind of a semantic differentiation that's maybe a little difficult to grasp at first. But if we said that this interval overlaps the truth 95, or that the truth is contained in this confidence interval 95% of the time, that would sort of imply that the truth is variable. The truth is not variable. The truth is the truth. And it doesn't vary. It is here. And the confidence interval clearly varies each time you do the study. So 95% of the time, the confidence interval is going to overlap the true mean. But for purposes of reading the literature, when a person, an author, gives you a confidence interval, he's saying this is how close we are to the truth. It's somewhere, you know, you can't really say it's somewhere in this interval, but you can say that the smaller the confidence interval, the more confident we are that our estimate from the sample is pretty close to the truth. So we look at our formula for standard deviation. We see that we have an average deviation, the sum minus the mean, these observations, these differences, divided by n minus 1. That's kind of like an average. We square it and take the square root. The standard error can't be measured directly because it's theoretical. But if we were going to write it like this, we could write it like this and say it's a sample mean minus the true mean divided by n. So that's because the standard error is a standard deviation of the sampling distribution of means. but we estimate that because we can't calculate it by taking the standard deviation divided by the square root of n. So again, to summarize, standard deviations measure variability of observations. Standard errors give you a measure of the accuracy of the mean. Standard deviations are based on direct observations, where standard errors are theoretical constructs. Standard deviations describe variability of the data. Standard errors just let you know how much means would, how great a variable, given a particular sample size, how likely, what the variability is around the truth. A standard deviation is the average deviation from the mean. Standard error is the average deviation from true means, from an infinite possibility of means. Increasing the sample size leads to a more accurate estimate. It could be bigger or smaller as you increase it. Increasing the sample size always leads to a more accurate estimate of the underlying truth. Always leads to it. And we see that because it's the standard deviation divided by n. So the bigger the n, the smaller the standard error is going to be. Standard deviation directly calculated, standard errors derived. The 95% prediction errors plus or minus 2 standard deviations. 95% of the people approximately in a symmetrical distribution of observations are going to fall between plus or minus 2 standard deviations. A 95% confidence interval, nothing to do with observations. So actually most of your observations are going to fall outside the confidence interval, because it's just talking about the mean, not the variability of the observations. Really, a 95% confidence interval does not inform you about